Good afternoon, Wolfpack, and welcome to lessons 16, 2, and 3, arc length and radian measure, as well as sector area. After today's lesson, you should be able to find the measure of an arc length and the area of a sector. So we've combined a couple of lessons here, taking some previous knowledge, adding a little bit more new knowledge in, and then hopefully you should feel very confident with what we're talking about. Arc length is finding a piece or a part of the whole circumference. Okay, you can use the word piece or part, whatever makes you happier. The formula for arc length is S equals the measure of the angle divided by 360 times 2 pi r, which is obviously the circumference formula. Okay, S means arc length, the length of the piece of the arc that we're looking for. If you would rather use a proportion instead, you can use a proportion where S, the arc length, divided by the circumference is equal to the measure of the angle divided by 360. I tend to use more of the formula style. This is kind of like what I like to do. But if you like proportions and you like cross multiplying and then dividing, that proportion style may be for you. So it's totally your call. Whatever makes you happier. So using this picture, obviously R is the radius, M is that measure of the arc length. Okay, so let's put it into action. Find the length of the darkened arc. So first of all, I'm going to write my formula down. S is the measure of the angle, the central angle, divided by 360 degrees. 360 degrees because it's 360 degrees of a circle, times 2 pi r. Okay. So the arc is 120 degrees as well as the central angle is 120 degrees. Okay. So we have S equals 120 over 360 times 2 pi, and the radius is 9. Okay. So I'm going to go ahead and reduce. I know that this can reduce down to 12 over 36. 12 can go to 12 one time, and 12 can go to 36 three times. So this reduces down to 1/3 times 2 pi r, which is 9. Okay, give myself a little bit more room here. Nine times 2 is 18. 18 times 1 is 18, divided by 3 is 6, so 6 pi, and our units are in inches, so you could say 6 pi inches, or you can convert that 6 times pi, let's go to 3 decimal places, we get 18.4, sorry, 0.849. Let me reset it right there again, 18.849. We're not talking about area, so it's not square. It's just plain old inches. So this formula right here is what you should be very, very comfortable with. 2 pi r. That's the circumference formula. All you're doing now is multiplying it by the measure of the angle or arc divided by 360. Again, basically all that you're doing is you're finding the part of the circumference. So you have to figure out what portion of the circumference you need. For example, for this problem, I needed just this part, which was 120 degrees out of 360 degrees, which was 1/3 of the circle. So that's why we multiplied 1/3 by the circumference formula. Okay? So don't let this seem, oh my goodness, this is crazy, a lot more to memorize. No, you're figuring out what portion or what piece of the circumference do you need, because that's the arc length. Example 2 we will do in class. Next up, we're going to talk about converting degrees to radians. We do everything in degrees in geometry in high school. But if you're going to have a math degree, you're going to have to learn about radians. And we are going to get very, very, very basic into it. You can research it on your own if you want to, but basically we're going to take degrees and make it to radians or radians and make it into degrees. So basically, 360 degrees is equal to 2 pi. And so 360 degrees, obviously around a circle, which is equal to 2 pi radians. So obviously, that means that 180 degrees would then just be 1 pi, because if I divide this by 2 and divide this by 2, this would be 180, which equals pi. So if I have something in degrees and I want to multiply it and change it into radians, I'm going to multiply what I have by pi over 180. Okay, pi over 188 degrees. But the opposite is true if I want to go from radians to degrees. If I have radians and I want to change it to degrees, I multiply it by 180 degrees over pi radians. And the way you're going to have to remember this, obviously it's just pi and 180. You have to figure out which one is which. But whatever one you're trying to get rid of is the one that goes on the bottom. So for example, if I have 360 degrees and I want to change it into radians, I'm going to multiply it by pi over 180 degrees, because then those degrees cancel each other out. Okay? So if I'm wanting to change it into, if it's in degrees, degrees goes on bottom. If it's in radians, pi radians goes on bottom, because that's what I'm trying to get rid of. So we'll do a couple of examples. Example 3, letter A. Here's an example of one. Convert each angle measure to radian measure. Convert each angle measure to radian measure. So I have 180 degrees. Oh my goodness, not 18. 180 degrees. And if you want to put it over 1, if that makes you happy, feel free to. And I'm going to change it into radians. I need to get rid of the degrees. So the degrees are going to go on bottom. And then pi is the numerator. So degrees cancels out. Okay. These cancel out because 180 goes into 180 once, and 180 goes into 180 once. So now we just have pi over 1, or just simply pi. Okay. Which we kind of already knew because of because of this problem. Okay. 180 degrees equals pi. So let's go the other way now. We're going to convert to degrees. I'll have pi divided by 4 radians. And so I'm going to take pi divided by 4, and I'm going to multiply it by 180 degrees over pi. Okay? So these are canceling each other out. I'm cross-canceling. It becomes 180 degrees divided by 4. 180 degrees divided by 4 is, I believe, 45. The only unit that's left is the degrees, 45 degrees. And degrees are a unit, just like inches and feet and miles. Okay, those are units. You have to have that degrees there. Simple as that. The hardest thing to do is going to remember that if you're changing it to radians, you multiply it by pi over 180. If you're changing it to degrees, you multiply it by 180 over pi. Okay? Hardest thing to remember is which one is which. Okay, so at the beginning of the lesson, we talked about finding the area of an arc length. I'm sorry, the length of an arc. Sorry, the length of an arc, or a piece of the arc, which is, an arc, which is a piece of the circumference. So now we're going to move into finding the area of a sector, which is kind of like finding a piece of the whole area. We were finding a piece of the circumference before, now we're going to find a piece of the whole area. And just like the last problem was a portion of the circumference, now we're looking for a portion of the area. Notice this is the area formula, okay? It's not a whole new formula to memorize, it's just the area formula being multiplied by something. And you're multiplying it by what portion of the circle that you need, okay? It's as simple as that. You're multiplying it by the portion of the circle. And you can turn it into an equation as well if you'd like to. Proportion if you'd like to. I prefer using the equation. It just makes more sense in my mind. But if you love proportions and cross multiplying and dividing, then you are more than welcome to use your proportion instead. And I will do some examples of proportions in class, but not for the video. Okay, example 5, letter A. The only example we'll do in the video, and then we'll do the rest in class. Find the area of each shaded sector as a multiple of pi and to the nearest hundredth. Okay, so the formula is area equals the measure divided by 360 degrees times pi r squared. So we're going to replace everything that we have with, we'll replace everything that we have. So the area equals, we need the shaded part, so 210 degrees. The central angle is 210, which means the arc is 210 degrees as well. 210 degrees divided by 360 times pi, and then our radius is 3. So 3 squared. Okay. I can see that this reduces by 10, so 21 over 36. I also see that 3 can go to 21 7 times, and 3 can go to 36 12 times. So this reduces down to 7/12 times, and then 3 squared is 9, 9 pi. Okay? So now, 9 times 7 is 63 over 12 pi. Okay? 63, so this is one answer. 63, 3 can go into 63 21 times. And into 12 4 times, so 21 divided by 4 pi. And you can turn 21 divided by 4 into a decimal. So 21 divided by 4 is 5. Let me give myself a little more room. Notice I'm keeping it in terms of pi. So 63 divided by 12 reduced to 21 over 4, which 21 over 4 as a decimal is 5.25. So all of these are options, and this is, the units are inches squared, inches squared, inches squared, because we are talking about area. Even though it's area of a sector, it's still area. So that's in terms of pi. They also went to the nearest hundredth, so 5.25 times pi to the nearest hundredth is 16.49 inches squared. And if you're not getting exactly the same answer I am, make sure you're using the pi button on your calculator. That could be why. Okay, so as in conclusion, big things we need to know. Arc length is finding a piece of the circumference. So you're taking the circumference formula and you're multiplying it by the measure of the arc divided by 360. What portion of it you are looking for. And then area of a sector is the same thing. You're taking the area formula and you're multiplying it by the piece of the arc or central angle divided by 360. So not technically a new formula to memorize. It's a building on a formula you should already know. You're just multiplying it by the angle divided by 360. Okay, please make sure you have this done, and I will see you next class. Have a great day.